Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So people, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Let me know quickly in the chats with some fire emojis. Quickly people, quickly. Good evening and welcome back. Good evening and welcome back. Good evening and welcome back. Perfect. I think I'm perfectly audible and visible to everyone. Yeah? Am I? Am I? Perfect, guys. Perfect. So, my dear students, as you all must be familiar with the fact that today we are going to start a new chapter, one of the most important chapters of your inorganic chemistry. And what do you call this particular chapter as? Chemical bonding, right? And my dear students, you should know from this particular chapter, every year almost like 4 to 5 questions are asked. Every year in your NEET examination, almost 4 to 5 questions are asked from this particular chemical bonding chapter. Number one. Number two, if you want your organic chemistry to be strong, then this chapter has to be stronger. If there is a problem in chemical bonding, your organic chemistry can never become that stronger. Okay, so try to make sure that this chapter becomes your strongest chapter when it comes to your inorganic chemistry. And this particular session is not just going to be for the NEET 2025 aspirants, it is going to be also for the NEET 2026 aspirants. If you have studied the chapter before or if you have not studied this particular chapter before, does not matter. Does not matter. I'll be starting all the things from the basics. I'll be starting all the things from the scratch as if you have never studied this particular chapter before, right? And my dear students, before starting this particular session, I would want every one of you to smash the like, right? To share this particular video with everyone. Whosoever is preparing for NEET 2025 or even 2026, this particular session is for every one of you, right? So do share this particular video with everyone. And the duration of this particular session will be almost 2.5 hours, something like that. Okay? And I'll try to cover this particular chapter in 2 sessions. If not 2, then maximum in 3 sessions, I'll be covering this particular chapter. Okay? And at the same time, the session PDF, the handwritten PDF, I'll be sharing on my Telegram channel. If you are not the part of my Telegram channel, you guys join the Telegram channel right now. And its name is Wasim Bhatt Chemistry Official, right? Wasim Bhatt Chemistry Official is the Telegram channel name on which I keep on sharing all the handwritten PDFs right after the session ends. Yeah? Perfect. Hello then. Let's get going. Let's get started with the chapter Chemical Bonding, one of the super important top chapters of your class 11th chemistry. Perfect. So people, let's get going then. Let's get started. First of all, if you ask me, the name of the chapter, it's chemical bonding, right? So what is a chemical bond, first of all? How do you exactly define a chemical bond? My dear students, it's a very simple terminology. Chemical bond. Any force of attraction that holds the constituent particles together. Any force of attraction that holds the constituent particles together, that's something which you call as chemical bond. For example, you have got NaCl, sodium chloride. In your sodium chloride, you have got Na positive, you have got Cl negative. There is a force of attraction between Na positive and Cl negative. That force of attraction is something which you call as chemical bond. For example, you have got H2 molecule. Right? Between 2 hydrogen atoms, there is some force of attraction. Between 2 hydrogen atoms, there is some force of attraction, which is holding them together. And any force of attraction that holds the constituent particles together, you call that particular force of attraction as the chemical bond. So in short, I must say, chemical bond is nothing. It is just the force of attraction that holds the constituent particles together. Okay? Point number one. Point number two. Now, what are basically the types of the chemical bonds? What are the types of the chemical bonds that we have to study in detail in this particular chapter? Let me give you the overview of certain things, okay, so that you get the idea of, so that you get the insight of what all things we have to cover in this particular chapter. My dear students, types of a chemical bond. Chemical bonds we broadly classify into two types. Chemical bonds we broadly classify into two types. One is called as primary bond. One is called as primary bond. Another one is something which you call a secondary bond. Primary bond and secondary bond. First of all, what is a bond? Bond is the force of attraction, right? The first type of chemical bond is your primary bond. The second type of the chemical bond is your secondary bond. Okay? When it comes to primary bonds, primary bonds are basically the strong bonds. These are basically the strong bonds. I'm just giving you the overview of the things. And all this I'm going to teach you in detail. Right now, I'm just giving you the overview of the things. Right? Primary bond. These are basically the strong bonds. When it comes to the secondary bonds, these are basically the weak bonds. These are basically the weak bonds. When it comes to the primary bonds, the bond energy is between 200 to what? 200 to 400 kilojoules per mole. 200 to 400 kilojoules per mole. In case of weak bonds, it is from 2 to 40 kilojoules per mole. So basically, the energy required to break 1 mole of primary bonds, that is between 200 to 400 kilojoules, right? And the energy required to break 1 mole of secondary bonds, that lies between 2 to 40 kilojoules per mole, right? So this much amount of energy, between 200 to 400 kilojoules, this much amount of energy is required to break 1 mole of primary bonds. Now, between 2 to 40 kilojoules, this much amount of energy is required to break 1 mole of secondary bonds. Okay? Now, what are the examples of the primary bonds? What are the examples of the primary bonds? My dear students, ionic bond, which we are going to study in detail in this chapter. This is the example of the primary bond, right? Similarly, your covalent bond, this is again what? This is again the example of your primary bond, which are stronger bonds, okay? Even you can write coordinate bond separately here also. You can write this coordinate bond as well, which is anyways the covalent bond only. Still, I'm writing it separately, right? These are the examples of what? Your primary bonds. If you talk about the secondary bonds, these are the weak bonds, and this involves your van der Waals force of attraction. It involves the van der Waals force of attraction, number one. Number two, it involves hydrogen bonding as well. It involves hydrogen bond as well. Okay. So this is just the classification of the bonds which we have to do in detail in this particular chapter. Okay. This is just the classification of the bonds which we have to do in detail in this particular chapter. Right? Right, people? Is it clear till here? Is it clear till here? I'm looking at your chats only. Well, I think I need to turn some lights off. Just a second. I think I need to turn some lights off. Now I believe it's fine, yeah? Just a second. Let me fix the lighting part first. It's always an issue in my session. Yeah? Okay, I think now it's perfect. So, my dear students, when it comes to chemical bond is nothing. It is just the force of attraction that holds the constituent particles together. Now, that force of attraction can be strong. That force of attraction can be weak, right? That particular bond which is strong, you call that as a primary bond. That particular bond which is weak, you call that as the secondary bond. in order to break 1 mole of primary bonds, how much energy is required? 200 to 400 kilojoules of energy is required to break 1 mole of primary bonds. And 2 to 40 kilojoules of energy is required to break 1 mole of secondary bonds. The examples of the primary bonds are your ionic bond and the covalent bond. Similarly, the examples of your secondary bonds, these are your van der Waals force of attraction and the hydrogen bonds. Now, this particular chapter is entirely about the covalent bond. I would say this chapter is mainly about what? This chapter is mainly about the covalent bond. Okay? This chapter is mainly about the covalent bond. Basically, in this particular chapter, we have to discuss this covalent bond in very much detail. We'll be discussing the other types of bonds as well. We'll be discussing ionic bond as well, coordinate bond as well. Of course, we are going to discuss them. But in detail, we are going to discuss generally the covalent bond. Right? Right, people? So, let's get started then. Let's get started then with the covalent bonds. First of all, my dear students, there is one question that arises in your mind. Why a bond is formed? Why a bond is formed? This might be a general question in your mind. Why a bond is formed between the constituent particles? I'm going to write its answer in just one statement. I would say a chemical bond is formed. A chemical bond is formed just to increase the stability of the system. A chemical bond is formed just to increase the stability of the system. A chemical bond is formed just to increase the stability of the system. Point number 1. This will understand in detail in some time. First of all, I would want you guys to take a note of these points. Chemical bond is formed just to increase the stability of the system. Number 1. Let me tell you, bond formation is always exothermic. Bond formation is always exothermic. And what is an exothermic process? In which energy is released. So during bond formation, whenever bond is going to get formed between two atoms, for example, let's say bond has to get formed between two atoms, right? Bond formation, it is always exothermic. During bond formation, energy is always released by the system. During bond formation, energy is always released by the system. Energy is released by the system. And during bond formation, if energy is released by the system, now think over it. If energy is released by the system during bond formation, energy carried by the system decreases during bond formation. I'll say energy of the system decreases during bond formation. Energy of the system decreases during bond formation. Bond formation, since it's exothermic, during bond formation, energy is released. And if energy is released by the system, energy possessed by the system decreases. And you know, stability is inversely proportional to energy. Stability is inversely proportional to energy. So, during bond formation, if energy of the system decreases, so automatically stability of the system that increases. I would want you guys to remember these 3-4 points over here. These are very important. Number 1, what is a chemical bond? Any force of attraction that holds the constituent particles together. What do you call that force of attraction as? You call that as the chemical bond. Different types of chemical bonds I gave you. Now, why a bond is formed? Why a chemical bond is formed? A chemical bond is formed only to increase the stability of the system. And how stability of the system increases? By decreasing its energy. And how energy decreases? Because bond formation is always exothermic. Energy is released by the system. And during bond formation, if energy is released by the system, energy possessed by the system decreases, and as the energy possessed by the system decreases, stability automatically increases. Yes? Is this point clear to everyone? Now I'm going to make you understand all these points in detailed form. Let's try to understand, people, in detail why a chemical bond gets formed. Understand now. For example, I'm going to take over here 2 atoms. Understand, guys. Let's say I'm taking 2 atoms over here. This is, for example, your atom A, and imagine this is your atom B. Okay, I've taken 2 atoms. Let's say a bond has to get formed between these 2 atoms. Let's say a bond is supposed to get formed between these 2 atoms. First of all, this is the nucleus of atom A. Let's call this as Na. This is the nucleus of atom A. And for example, over here there is an electron. I'm calling this as electron of atom A. Similarly, I'm calling this as nucleus of atom B. And for example, this is the electron of atom B. Right? How many atoms have I taken over here? I have taken 2 atoms. Atom A, atom B. Okay? Now, my dear students, first of all, let's get to know what kind of forces arise between 2 atoms. What kind of forces arise between 2 atoms? What kind of forces arise between 2 atoms? Let's try to understand. First of all, my dear students, it's very much clear. This nucleus will be holding its electron towards itself. This nucleus will be attracting its electron towards itself. So the first force of attraction which you see over here, that's between nucleus of A and electron of A. Number 1. In this atom, this nucleus, it will be holding its electron. It will be attracting its electron towards itself. So over here, there is a force of attraction between nucleus of B and electron of B. What is the nature of these forces? It is basically the force of attraction. It is a force of attraction. It is a force of attraction between nucleus of A, electron A. Between nucleus of B, electron of B. Right? It is a force of attraction. Now, second guys, I would say this nucleus of A will be attracting electron of B towards itself as well. Yes, nucleus of A will be attracting the electron of B towards itself as well. So this force is also attractive in nature. This is the force of attraction between nucleus of A, electron of B. Similarly, nucleus of B and electron of A, this is again attractive in nature. Nucleus of B, electron of A, this force of attraction is attractive in nature. Okay. Now, my dear students, this nucleus and this nucleus, they'll be repelling each other. They'll be repelling each other. So nucleus of A and nucleus of B, they'll be repelling each other. Similarly, nucleus of A and nucleus of B, they'll be repelling each other. Similarly, electron of A and electron of B, they'll be also repelling each other. Electron of A, electron of B, they'll be doing what? They will be showing the repulsion. So if I ask you right now, how many forces arise between 2 atoms? How many forces arise between 2 atoms? I'll say 2 types of forces arise between 2 atoms. One is going to be force of attraction, one is going to be force of repulsion. 2 types of forces arise between 2 atoms. One is going to be force of attraction, one is going to be force of repulsion. And my dear students, remember from now onwards, attractive forces try to increase the stability of the system. Attractive forces try to increase the stability of the system. And when I talk about repulsive forces, they try to decrease the stability of the system. They try to decrease the stability of the system. Attractive forces, they'll be always trying to increase the stability of the system. And repulsive forces, they'll be always trying to decrease the stability of the system. Okay? They'll be always trying to decrease the stability of the system. Now, my dear students, understand and remember from now onwards. Whenever there'll be attractions between 2 atoms, whenever there is force of attraction between 2 atoms, energy is released by the system. Whenever there is force of attraction between two atoms, energy is released by the system. If energy is released by the system, energy possessed by the system decreases. And stability is inversely proportional to energy. Lesser the energy possessed by the system, more is going to be the stability of the system. As simple as that. As simple as that. Is it clear? Is this point clear to everyone? Whenever there is force of attraction between the atoms, wherever you see force of attraction between the atoms, energy is released by the system. And whenever energy is released by the system, energy possessed by the system decreases. If energy possessed by the system decreases, stability of the system increases. So force of attraction, it always tries to increase the stability of the system. And similarly, force of repulsion, it always tries to decrease the stability of the system. Right? So, take a note of this particular point. Whenever there are attractions between the atoms, energy is released. Energy is released. And if energy is released by the system, energy possessed by the system decreases, stability increases. Right? And whenever you see repulsions, due to repulsions, what happens? Due to repulsions, what happens? Energy of the system increases. Due to attractions, energy of the system decreases. Due to attractions, energy of the system decreases. And due to repulsions, energy of the system increases. Energy of the system increases. Energy of the system increases. And as the energy of the system increases, stability automatically decreases. Okay. Now, guys, this was a quick information. This was just the general information. Whenever you see two atoms, right? Between two atoms, how many types of forces arise? Two types of forces. Attractive force, repulsive force. Attractive force always leads to increase the stability of the system. And repulsive force always leads to decrease the stability of the system. Whenever there are attractions, energy is released. Energy is released. Stability is increased. Whenever there are repulsions, energy of the system increases. Stability decreases. So, in short, attractive forces, they try to increase the stability of the system. Repulsive forces, they try to decrease the stability of the system. These are two important points which I would want you guys to take a note of, right? Attractive forces and repulsive forces, what exactly they do. Okay? Now, guys, one more general information, because all these points are very important and you should know them. This is general information. This is general information which you'll use everywhere, right? See, guys, you know, force of attraction. Force of attraction is inversely proportional to what? Distance. Force of attraction is inversely proportional to distance. So, as the distance between the atoms is more, force of attraction is less. When atoms come closer, distance decreases. Distance between them decreases. And as the distance decreases, force of attraction increases. One simple point I'm telling you, right? Yes, one simple point. Why am I telling you this particular point? Because I have to plot a graph over here, which will make you understand all of this in detail. I'm going to plot a graph. Which will exactly make you understand how a bond gets formed. Okay? Try to understand, people. I'm plotting a graph between potential energy of the system versus the internuclear distance. Potential energy of the system versus what? Versus the internuclear distance. Now understand what exactly I'm going to say. My dear students, for example, if you select this particular point, at this particular point, R value is at this particular point, which is origin, R value is 0, right? R value is 0. If you go in this direction, the value of R is increasing. That means internuclear distance is increasing. That means distance between the atoms is increasing. Right? Let's say I'm taking a point on this r-axis somewhere here. Okay? Somewhere here. What does that mean? I'm trying to tell you, imagine that the atoms, the two atoms between which bond has to get formed. Imagine that the atoms which I'm taking. Let's assume the atoms between which bond has to get formed. Assume that the atoms are at infinite distance apart. Imagine that the atoms are at infinite distance apart. Imagine that you've got two atoms and you want these two atoms to form a bond. But right now, there's a scenario when the atoms are at infinite distance apart. And you know, if atoms are at infinite distance apart, force of attraction between atoms will be zero. When atoms will be at infinite distance apart, there'll be no force of attraction between them. There'll be no force of attraction between them. Now, imagine these atoms are approaching towards each other. Imagine these atoms are approaching towards each other. If these atoms are approaching towards each other, what is happening to the distance between the atoms? Distance between the atoms is decreasing. And if distance between the atoms is decreasing, force of attraction between the atoms increases. Force of attraction between the atoms increases. Initially, the atoms were at infinite distance apart. Force of attraction 0. Now these atoms are coming closer. Distance between them is decreasing. Force of attraction is increasing. Distance decreasing. Force of attraction increasing. Distance decreasing. Force of attraction increasing. So as the atoms approach towards each other, distance between them decreases. Force of attraction between them increases. And due to attractions, energy is released. So right now, atoms were at infinite distance apart. Right? Now imagine you are moving in this particular direction. If you are moving in this particular direction, what is happening to R value? R value is decreasing. R value is decreasing means the atoms are coming closer. As the atoms are coming closer, distance decreases, force of attraction increases. And force of attraction, due to attraction, energy is released. Therefore, if energy is released continuously, when the atoms are coming closer, energy is released continuously. That means energy of the system, that will be decreasing continuously. So as the atoms will be coming closer, distance between them will keep on decreasing, force of attraction will keep on increasing, energy will continuously keep on releasing. Therefore, energy possessed by the system will continuously keep on decreasing. Yes? Right? Potential energy of the system continuously keeps on decreasing as the atoms are coming closer. Initially, the atoms were at infinite distance apart. For example, this is the scenario when the atoms have slightly come closer. Now, there is one more scenario when the atoms have come a little more closer. As the atoms are coming closer, distance between them decreases, force of attraction increases. If force of attraction increases, continuously energy is being released. Energy possessed by the system decreases with time. So as the atoms come closer, energy of the system keeps on decreasing. And the system is moving towards stability. Right? My dear students, this is the point which represents the minimum potential energy of the system. And what does this point indicate? This point indicates that potential energy of the system is minimum. That means stability is maximum. That means at this point, when the potential energy of the system is minimum, at this point, I would say bond formation has taken place between the atoms. So at this particular point, I would say bond formation has taken place between the atoms. Okay, bond formation has taken place between the atoms. Now, my dear students, I would say right now, these atoms are at maximum closest distance. Now, when the atoms are at maximum closest distance, the force of attraction between these atoms is maximum right now. Energy of the system is minimum right now. Stability of the system is maximum right now. Now, right after this particular point, if you still want to go in this direction, that means if you still want to decrease the value of R, that means you want these atoms to come further more close. If you want these atoms to come further more close, which forces will arise now? Repulsive forces are going to start now. And repulsive forces, they try to increase the energy of the system. Repulsive force after this point, they will try to increase the energy of the system. My dear students, let me tell you, the distance from hair to hair is something which you call as bond length, right? And the energy gap from hair to hair, you call this energy gap from hair to hair as bond energy. Is this particular graph clear to everyone? Let me know once in the chats. Let me know once in the chats if this particular graph is clear to everyone. So I would say this is the point at which energy of the system is minimum. Energy of the system is minimum means stability is maximum. When is the stability maximum? When bond gets formed. And when the bond gets formed, the atoms will be at maximum closest distance. Force of attraction will be maximum. If force of attraction is maximum, energy of the system is minimum. If energy of the system is minimum, stability is maximum. Yes. If it is clear till here, let me know in the chats quickly with the thumbs ups. Everyone, people, everyone. Yeah? I hope this is clear to everyone. Shiva Prasad, you can consult chemistry videos from this channel only. It's okay. Okay? Because the content which I'll be giving you, it is for both NEET as well as JEE Main students. It's not only for NEET students. Purely for NEET as well as Main students. Perfect? I believe all the things are clear till here. Now, people, I'm moving ahead. I hope this particular graph is clear. I hope this particular graph is clear. Just let me know once in the chats. Just a second, guys. I want to see exactly whether this particular graph is clear to you. I want to see whether this particular graph is clear to you or not. And you are honestly going to tell me whether this particular graph is clear to you or not. Then only I can move ahead. And if this particular graph is clear, let me give you one question. Let me see if you can answer this particular question or not. The question is, the variation of potential energy with the internuclear distance. The variation of potential energy with the internuclear distance between atoms A and B. Between atoms A and B is given as UR is equal to 6 divided by R square plus 3R plus 2. This is the variation. In the question, I'm asking you to calculate the bond length. Calculate the bond length in angstroms, for example. Calculate the bond length in angstroms. Have you seen this sort of a question before? It's a simple question, guys. Variation of potential energy versus the internuclear distance is given. We are supposed to calculate the bond length. Now, guys, understand one thing. If you look at this particular graph properly, right? At this point, energy of the system is minimum. Bond has got formed, right? Bond has got formed at this particular point. Bond has got formed. And the distance from here to here is something which I call as bond length. Now, look at this particular point. If you draw the tangent here at this particular point, if I ask you, what is the slope of this tangent at this particular point A, for example? So you'll say slope of the tangent over here is equal to 0. Slope of the tangent at this particular point is equal to 0. Now, slope is equal to 0. What does that mean? That means slope. Slope is du upon dr here. dy by dx is slope. Now, along y-axis is potential energy. Along x-axis it's r. So, instead of dy by dx, I'm writing du upon dr. Du upon dr represents slope of the tangent. It represents slope of the tangent at a point. Slope of the tangent at a point on potential energy versus R curve, right? Perfect. So this is the condition which I'll be using, people. This is going to be the condition which I'll be using to calculate what? To calculate the bond length. This is the condition which I'll be using to calculate the bond length, right? Now, my dear students, I'm given with the equation. U is equal to this plus this plus this. Calculate the bond length. Now, at bond length. In order to calculate bond length. In order to calculate bond length. In order to calculate bond length, what do I need to do? I know slope of the tangent at a point on U versus R curve, right? That has to be 0 when it comes to the calculation of bond length, right? So what I'll be doing, I'll be just differentiating du upon dr. Du upon dr, just differentiate. 6, you are writing as such. 1 by r square differentiation, quickly. It's going to be what? It's going to be minus 6 upon r cube. Perfect. 3r differentiation is just going to be 3. Okay. It's just going to be 3. And differentiation of constant here is 0. Now, this value has to be equal to 0. If this value has to be equal to 0, so minus 6 divided by r cube is equal to minus 3. Minus cancelled out. So I would say 3r cube is equal to 6. So r cube is equal to 2. I'll say r is equal to 2 raised power 1 by 3 angstroms. Right? R is equal to 2 raised power 1 by 3 angstroms. So this is the final answer of the question. Is this clear? Yeah? Right, people? I believe this is clear. I believe this particular point is clear to everyone. So whenever a potential energy versus internuclear distance relation is given to you and you are supposed to calculate bond length, what are you supposed to do? Simple. What exactly you are supposed to do? What exactly? Did I miss something here? I think I missed something. Okay, yes, it's 12. It's 12. It's not 6. Sorry, I missed something. Just a second. It is 12 here, right? It is going to be 12 here. Just a second. This is going to be 12 here. Okay, let me do this calculation a bit again. This is going to be 12 is equal to 3r cube. So r cube is equal to 4. So r is equal to 4 raised power 1 by 3. So this is the answer of the question. Yeah? That's something which I missed. I believe whenever you see this sort of a question, you should be in a position to solve it on your own. Okay? Now, I'm moving on to the actual stuff, but before moving on to the actual stuff, tell me in the chats whether all the things are clear to you or not. Perfect, guys. Perfect. Now, let's move on to the covalent compounds. Well, first of all, if I ask you what is a covalent compound, or before leave the covalent compound aside, if I ask you what is a covalent bond, what is a covalent bond? There are a lot of theories which have been given. There are a lot of theories which have been given, which we are going to discuss in detail in this chapter, by means of which you'll get to know what a covalent bond is. The first theory is very much simple, which I believe every one of you will be knowing. That is the Lewis-Langmuir concept. The Lewis-Langmuir concept of a covalent bond. First of all, as per this particular theory, you should know a covalent bond is formed between the two atoms by the mutual sharing of electrons. A covalent bond is formed between the two atoms by the mutual sharing of electrons, just to complete their octets or duplets. Just to complete their octets or duplets. And the number of electrons contributed by each atom is something which you call as covalency. Now, what is meant by all this? Let's try to understand this in detail. See, guys, for example, let's say I've got F2 molecule over here. Let's say over here I'm taking O2 molecule. Let's say over here I'm taking N2 molecule. These are the 3 molecules which I've taken over here. Understand properly what exactly I'm going to say. First of all, imagine this is one fluorine atom. Imagine this is one more fluorine atom. If I ask you, how many electrons are in the outermost shell of fluorine? You'll say in fluorine there are 7 electrons present in its outermost shell. So 2, 4, 6 and 7. Fluorine has got 7 valence electrons. Similarly, this particular fluorine, sorry, I'm talking about fluorine. This fluorine also, it has got the 7 valence electrons. Okay. This fluorine, 7 valence electrons. This particular fluorine, again 7 valence electrons. Now tell me one thing. How many electrons this fluorine needs to complete the octet? 1. How many electrons this fluorine needs to complete the octet? 1. Right? They need one electron to complete their octets. So what they exactly are going to do? They are going to give 1 electron each. And that 1 electron, which is given by each, so that means I'm talking about this electron pair. This electron pair is mutually shared by both the atoms. This electron pair is mutually shared by both the atoms. And whenever you see mutual sharing of electrons happening, understand a covalent bond gets formed. So which bond got formed here? A covalent bond got formed, right? Why there is a mutual sharing of electrons? Just to complete their octets. Now, if you check the octet of this fluorine, 2, 4, 6, 8. If you check the octet of this 2, 4, 6, 8, octet of both the fluorine atoms is completed. Remember, since this fluorine, it contributes 1 electron, this fluorine also contributes 1 electron. Whenever both the atoms contribute 1 electron each, whenever both the atoms contribute 1 electron each, a single covalent bond gets formed. Since both the atoms are contributing 1 electron each, so a single covalent bond has got formed here. And the number of electrons contributed by each atom, that defines its covalency. So covalency of this particular fluorine here is 1. Covalency of this particular fluorine here is 1, because both the fluorine atoms are contributing 1 electron each. Right? Now, my dear students, this electron pair which you're seeing at the middle, which is common to both the fluorine atoms, right? You call this particular electron pair as the bonded electron pair. This is called as bonded electron pair, right? Now, if you talk about this particular electron pair, I'll say this particular electron pair, or even this particular electron pair, or even this particular electron pair. This one, as well as this one, as well as this one. These are the electron pairs which belong to the valence shell of the fluorine. These are the electron pairs which belong to the valence shell of fluorine, but did not participate in the bonding. And those electron pairs which belong to the valence shell of the atom, but do not participate in the bonding, what do you call that electron pair as? You call this either as a lone pair, or you call this as non-bonding pair. You call this as a non-bonding pair. Either lone pair or non-bonding pair. Which one? That electron pair which belongs to the valence shell of the atom but does not participate in the bonding, that's called as lone pair or non-bonding pair. Look at this oxygen, O2 molecule. If you talk about O2 molecule, let's say this is one oxygen atom, this is one more oxygen atom. In the valence shell of oxygen, how many electrons are there? There are 6 electrons in the valence shell of oxygen. Look at this particular oxygen. Again, there are 6 electrons in the valence shell of this particular oxygen. Is the octet of this oxygen complete? No. Is the octet of this particular oxygen complete? No. How many electrons this oxygen needs to complete the octet? It needs 2 electrons. Even this one needs 2 electrons. So what they both are going to do? This oxygen is going to give its 2 electrons. Even this is going to give its 2 electrons, right? Okay. Now these 4 electrons, which I'm calling as 2 electron pairs, these 2 electron pairs, they will be mutually shared by this one as well as this one, right? So these 2 electron pairs which are mutually shared, between these 2 atoms, I call them as the bonding pairs. Right? And my dear students, similarly, this electron pair, this one, I'll be calling them as the lone pairs or non-bonding pairs. Okay? Now, each atom, oxygen, it contributed 2 electrons. This oxygen contributed 2 electrons. Whenever each atom contributes 2 electrons to form, remember, at that point of time, a double covalent bond is formed. A double bond gets formed. When a double bond gets formed? When each atom contributes 2 electrons. Simple. Yes? Simple. Okay? Similarly, the number of electrons contributed by each atom, that defines the covalency. So covalency of this oxygen is 2 here. This oxygen's covalency is also 2, right? The number of electrons contributed by each atom, that's something which you call as covalency. Perfect. Similarly, my dear students, talk about N2 molecule. How this N2 molecule gets formed? So take one nitrogen atom, take one more nitrogen atom. In the valence shell of nitrogen, there are 5 electrons. In the valence shell of nitrogen, there are 5 electrons. Now this needs 2 electrons. This needs 3 electrons to complete the octet. This needs 3 electrons to complete the octet. Now what they are going to do? Both the nitrogens are going to contribute 3 electrons. Both the nitrogens are going to contribute 3 electrons here. Okay. Both the nitrogens are going to contribute 3 electrons. Perfect. 3 electrons means 2, 4, and 6. Perfect. Now these 3 electron pairs, they'll be mutually shared by this nitrogen as well as this one, right? So again, covalent bonds have got formed. Mutual sharing of electrons is happening, right? And when each atom contributes 3 electrons each, which bond gets formed? A triple bond gets formed between 2 atoms. The number of electrons contributed by each atom, that defines its covalency. So covalency of the nitrogen is 3, right? So how many bond pairs do you have here? You have got 3 bond pairs. What do you call this particular electron pair as? You call this as the lone pair or the non-bonded pair. I believe this is clear to everyone. Right? Right, people? Yeah? I believe this is clear to everyone. This was just the basics. This was just the basics. Now, my dear students, comes something very important. And what is that important thing? What is that important thing? Try to understand properly. The first type of the question which will be asked, from chemical bonding, what is that? How do you draw Lewis structures? How do you draw, how you guys draw the Lewis structures? How exactly you guys will be drawing the Lewis structures? Now let me exactly teach you how to draw the Lewis structures. Understand and remember things. Understand and remember things. Okay? Someone is saying, sir, please smile. It's better to focus on the screen. Right? Okay, guys? Now understand, this is going to be super important. How do we draw the Lewis structures? Remember point by point. Point by point. See, guys. For example, you have got a molecule carbon monoxide, CO. I need to draw its structure as per Lewis. Okay? As per Lewis, I need to draw its structure. How exactly you guys are going to draw its structure? Understand. First of all, you have got carbon, you have got oxygen. Tell me how many valence electrons are there with carbon? 4. How many valence electrons are there with oxygen? 6. Now, how many total valence electrons do you see here? 10. If there are 10 valence electrons in total, if I ask you how many valence electron pairs do you see? 5. 5 valence electron pairs means 10 valence electrons. So there are 5 valence electron pairs, right? There are in total 5 valence electron pairs. Now, I have to arrange these 5 valence electron pairs. How exactly? Have a look. You have got carbon, you have got oxygen, right? Carbon, oxygen. The first thing which you guys will be doing, just draw a single bond here. Just draw a single bond. Drawn. Single bond means 1 electron pair. Single bond means 1 electron pair. How many you had? 5. Out of 5, how many have you used? You have used 1 electron pair. So how many electron pairs are left? 4 electron pairs are left. 4 electron pairs are left. Now, right after this point, right after drawing one bond, what exactly you guys are going to do? You guys are going to fill the octets of this oxygen as well as carbon. And you'll be starting with more electronegative element. Start filling the octet of more electronegative element now. Which one is more electronegative among the two? Oxygen. Start filling the octet of oxygen. See, 2 already you can see. This is 2. 2 already you can see. So 4, 6, 8. Its octet is complete now. The octet of oxygen is complete. Now, my dear students, tell me one thing. 2, 4, 6, and 8. Its octet is complete. How many electron pairs I had? 5. Out of 5, how many have I used? I've used 1, 2, 3, and 4. 4 electron pairs I've used. 1 electron pair is left. Give that electron pair directly to what? Give that electron pair directly to carbon. Okay? Now, my dear students, check whether the octet of carbon is complete or not. Octet of carbon is not complete. 2 and 4. It's not complete. We need to complete the octet of carbon as well. So what I'll be doing in order to complete the octet of carbon, I'll be removing 1 electron pair from oxygen, and instead of this electron pair, put a double bond. I'll be removing 1 more electron pair from the oxygen, and instead of this electron pair, put a 1 more bond. Now check and confirm. Now confirm the octet of carbon as well as oxygen. Is the octet of carbon and oxygen complete? 2, 4, 6, 8. 2, 4, 6, 8. Octet of both atoms is complete. Yeah? Right, people? Octet of both atoms is complete now. If the octet is complete, Now, one more thing I'm going to ask you here. Do you see any charge on oxygen here? Or do you see any charge on carbon here? From this particular structure, I cannot see any charge on carbon or oxygen. Let's get to know, is there any charge on carbon or oxygen? Which I'm calling as formal charge. So how do I calculate the formal charge on the atoms? For example, I'm talking about the formal charge of carbon. How do you calculate the formal charge of carbon? How do you calculate the formal charge? First of all, I'm talking about carbon. Imagine you have got carbon in non-bonded state. In non-bonded state, how many valence electrons carbon has? 4 minus. In non-bonded state, it has got 4. It has got 4 valence electrons. Now, in this bonded state, how many do you see? 1, 2. Out of this bond, just consider 1. Out of this bond, just consider 1. Out of this bond, just consider 1. So 1, 2, 3, 4, 5. In bonded state, it has got 5. So 4 minus 5 comes out to be minus 1. So formal charge on carbon here is basically minus 1. What about the formal charge on oxygen? Calculate for oxygen as well. Oxygen when present in non-bonded state. Oxygen when present in non-bonded state has got 6 valence electrons. Right now in the bonded state, how many it has? 1, 2. Right? Out of this bond, consider 1. Consider 1. 1, 2, 3, 4, 5. So 6 minus 5 comes out to be plus 1. Right? So formal charge of this oxygen here is plus 1. So one is carrying minus 1, one is carrying plus 1. That's all. Right? So this is how you draw the structure with the formal charges. Right? Plus 1 and minus 1 respectively. Okay? Plus 1 and minus 1 respectively. Now, my dear students, let's take few more cases, few more examples so that you'll understand it properly. For example, you have got the molecule NO2 negative. First of all, tell me the total valence electrons. Nitrogen has got 5 valence electrons. Oxygen has got 6 valence electrons. 6 2s are 12. Right? There's a negative charge. If there's a negative charge, add that negative charge. If there's a positive charge, subtract that positive charge. So in total, how many valence electrons do you have? 12 plus 1, 13. 13 plus 5 is 18. So 18 valence electrons in total. If there are 18 valence electrons in total, if I ask you how many valence electron pairs do we have? We have 9 valence electron pairs. Now, my dear students, it is high time to arrange these 9 valence electron pairs between the atoms. Now, how many atoms do you see? 3 atoms. Nitrogen and 2 oxygen atoms. Right? Now, which one you'll be calling as the central atom? The one which is less electronegative, you'll be calling that as the central atom. So nitrogen, here is the central atom. This is oxygen. There's one more oxygen. Correct? Now do one thing. Put a single bond here. Given 2 single bonds. Now after giving the single bonds, how many valence electron pairs do we have? 9. Out of 9, how many we have used? 1 and 2. 2 electron pairs we have used. Out of 9, we have used 2 electron pairs. How many are left? 7. Now start filling the octet of more electronegative element. Which one is more electronegative? Oxygen. So start filling the octet of oxygen. 2, 4, 6, 8. Octet of this oxygen is complete. 2, 4, 6, 8. Complete. How many electron pairs I had? 9. Out of 9, how many I've used? 1, 2, 3, 4, 5, 6, 7 and 8. 8 I've used. 1 is left. Give that directly to this nitrogen. Octet of this oxygen is complete. But is the octet of nitrogen complete? No. Check it out. 2, 4 and 6 only. Now what you need to do? Out of these 2 oxygen atoms, select anyone, remove one of the electron pair, and instead of that electron pair, put a double bond here. That's all. This is your structure of your NO2. This is the structure of your NO2. Now if I ask you, are there any charges on the atoms? Basically, I'm talking about the formal charges. Let's say call this oxygen, call this atom 1, call this atom 2, and call this as atom 3. Okay? On atom 1, what will be the formal charge? On the atom 1, what will be the formal charge? Atom 1 is oxygen. In non-bonded state, it has got 6 valence electrons. Now, in the bonded state, how many it has? 1, 2, 3, 4, 5, and 6. So 6 minus 6 is equal to 0. So formal charge on this oxygen is 0. Look at the second oxygen. Look at the second oxygen. Look at the second oxygen. In non-bonded state, it has got 6 valence electrons. Minus. In bonded state, how many it has? 1, 2, 3, 4, 5, 6, and 7. So 6 minus 7 comes out to be minus 1. So formal charge of this oxygen is minus 1. Look at the formal charge of nitrogen. Look at the formal charge of nitrogen. You should be in a position to do it as well. In non-bonded state, nitrogen has got 5 valence electrons. Minus. In bonded state, 1, 2, 3, 4, and 5. Right? So 5 minus 5 comes out to be 0. Perfect. So formal charge on this nitrogen here is 0. I believe I'm in clear. Yeah? Is it clear, guys? Is it clear? Is it clear? Is it clear, people? Quickly, let me know in the chats. Let me know in the chats. For example, I've got the molecule HCN. For example, I've got the molecule HCN. In hydrogen, how many valence electrons are there? 1. Carbon has got 4 valence electrons. Nitrogen has got 5 valence electrons. So 5, 4, 9 plus 1, 10. So in total, there are 10 valence electrons. 10 valence electron means how many valence electron pairs? 5 valence electron pairs. Now, which one should be the central atom? Less electronegative atom should be the central atom. Less electronegative element has to be the central atom. Again, I'm repeating. Less electronegative element has to be the central atom. But whenever you see in a molecule, whenever you see hydrogen or fluorine in the molecule, whenever you see hydrogen or fluorine in the molecule, remember hydrogen and fluorine, they always occupy the terminal positions. They do not occupy the central positions. Normally, how do we check the central atom? We see the less electronegative element. Less electronegative element is going to be your central atom. But remember, whenever you see hydrogen or when you see fluorine, hydrogen and fluorine, they'll be your terminal atoms. They'll be your terminal atoms. So here there is hydrogen. So it is going to be at the terminal position. Now carbon and nitrogen, which one is less electronegative? Carbon. So carbon has to be the central atom here. Carbon, this nitrogen, and this, for example, hydrogen. Okay. Now, what is the first thing which we'll do? We'll put a single bond, right? Done. Done. Right after this, how many electron pairs we have? 5. So adjust these electron pairs. Try completing the octet of more electronegative element. Which one is more electronegative? Nitrogen. Try filling its octet. 2 already there. So 4, 6, and 8. Okay. How many electron pairs I had? 5. Out of 5, how many I've used? 1, 2, 3, 4, 5. I've utilized all the 5 valence electron pairs. I've utilized all the 5 valence electron pairs. Now, people, is the octet of carbon complete? Check it out. 2, 4. No, it's not complete. So what am I supposed to do? Remove this electron pair, put a double bond. Remove this electron pair, put a double bond. Check the octet of this carbon now. 2, 4, 6, 8. Complete. Check the octet of nitrogen. 2, 4, 6, 8. Complete. Check the duplet of hydrogen. 2. Complete. Right? So this is the structure of your HCN as per Lewis is concerned. Now, talk about the charges. Are there any charges present on this nitrogen, this carbon, this hydrogen? Let's check it out one by one. Calling this is atom 1, calling this is atom 2, calling this is atom 3. Is there any charge present on atom 1? Is there any charge present on atom 1? Check it out. Nitrogen, in the non-bonded state, nitrogen has got 5 valence electrons. Minus. In the bonded state, 1, 2, 3, 4, 5. In the bonded state, it has got again 5. So 5 minus 5 is 0. So there is no charge on this nitrogen, right? Look at this hydrogen, or talk about the atom 2. Talk about the atom 2. Atom 2 is carbon. In non-bonded state, carbon has got 4 valence electrons. In bonded state, it has got 1, 2, 3, and 4. So 4 minus 4 is 0. This is non-bonded, this is bonded. Talk about hydrogen, the third atom. Hydrogen in non-bonded state has got 1 valence electron. And over here, it has got also 1. So 1 minus 1 is 0, right? So there is no formal charge. There is no charge on any of the atoms over here. I believe I'm clear to everyone. Okay, let me take a few more examples so that it becomes like properly clear to you. For example, you have got carbon dioxide molecule. Let's say you have got carbon dioxide molecule. What is the first thing I'm going to do? Calculate the valence electrons. Carbon has got 4 valence electrons. Oxygen has got 6, so 6 to the 12. So 12 plus 4 is 16. So 16 valence electrons in total. If I ask you, how many valence electron pairs? 8 valence electron pairs. 8 valence electron pairs. Okay. Now, which one is the less electronegative element? Carbon. Less electronegative element is the central atom. This is oxygen, this is oxygen. Put a single bond, put a single bond. Now start filling the octet of more electronegative element. So 2, 4, 6, 8. Done. 2, 4, 6 and 8. Done. How many valence electron pairs I had? 8. Out of 8, how many I have used? 1, 2, 3, 4, 5, 6, 7, 8. I have utilized all the 8 valence electron pairs. But, tell me one thing. Tell me one thing. Is the octet of carbon complete? No. Octet of carbon is not complete. 2 and 4. Octet of carbon is not complete. Remove this electron pair from here. Put a bond. Similarly, remove this electron pair from here. Put a bond. So this is your carbon dioxide. Now, calculate the charges on the atoms. This is atom 1. This is atom 2. This is atom 3. Calculate the formal charge on the atoms. On atom 1, is there any charge? In non-bonded state, oxygen has got 6 valence electrons. Right now in bonded state, 1, 2, 3, 4, 5, 6. So 6 minus 6 is equal to 0. Look at the second atom. Carbon. In non-bonded state, 4 electrons, 4 valence electrons. Right now in bonded state, 1, 2, 3, 4. So 4 minus 4 is equal to 0. Right? Third one. Oxygen. Non-bonded state, 6. And over here in bonded state, 6. 6 minus 6, 0. So no formal charges on each of the atoms over here. Am I clear? Am I clear till here? Say yes or no in the chats quickly. Say yes or no in the chats quickly if all the things are clear. Quickly, people. Everyone in the chats, quickly. Everyone in the chats, quickly. Yeah? Perfect. So let's have a look on the O3 molecule now. Let's have a look on the O3 molecule now. Shiva Prasad, I told you you can consult these lectures for your JEE mains as well. Do not spam, please. You can consult these lectures for JEE mains as well. Okay? I hope I'm clear to you. I hope I'm clear to you now. Okay? Syed Ibrahim, the notes will be provided on the Telegram. Telegram channel name is Wasim Bhatt Chemistry Official. Okay? All right, look at this O3, guys. Look at this O3. So first of all, if I ask you how many valence electron pairs do you have here? 6 3s are 18. Sorry, how many valence electrons do you see here? How many valence electrons do you see here? 6 3s are 18. So how many valence electron pairs will be there? 9 valence electron pairs. So there are 3 oxygen atoms like this. Put a single bond everywhere. Now since everywhere you have got oxygen, so start filling the octet of oxygen. So 2, 4, 6, 8. 2, 4, 6 and 8. How many I had? 9. Out of 9, how many I've used? 1, 2, 3, 4, 5, 6, 7, 8. Give 1 to this one. But no doubt, octet of this oxygen is complete. This one is complete. Octet of this oxygen is not complete. So complete it. What do you have to do? Select any of the oxygen atoms, remove the electron pair and put a double bond. That's all. Octet of all the atoms complete. Right? Now, call this as atom 1, call this as atom 2, call this as atom 3. Right? It is high time to calculate the formal charge on these atoms now. Atom 1, oxygen, non-bonded state 6, minus bonded state 1, 2, 3, 4, 5, 6. So 6 minus 6 is 0. Atom 2, oxygen, non-bonded state 6, bonded state 1, 2, 3, 4 and 5. 6 minus 5 comes out to be plus 1. So formal charge on this oxygen is plus 1 technically. Similarly, on this particular oxygen, how many in non-bonded state? 6. How many right now in bonded state? 1, 2, 3, 4, 5, 6 and 1, 7. So 6 minus 7 comes out to be minus 1. I hope you can draw the structures of all these simple molecules. complex molecule structures are not drawn as per Lewis. That was one of its drawback. That was one of its drawback. Okay, I believe I'm clear, guys. I believe I'm clear. For example, you have got Cn negative. Again, one simple one. Cn negative. Can you do all the calculation for Cn negative? You can. Can you do all the calculation for Cn negative, people? Okay, so first thing, what I'll be doing, I'll be calculating the valence electrons in total. Carbon 6, nitrogen 7. Right? Sorry, carbon 4, nitrogen 5. So carbon is 4 valence electrons. Nitrogen has got 5 valence electrons. There is negative charge, so add that negative charge. 5 plus 1, 6, 6 plus 4, 10. So how many valence electron pairs will be there? There'll be 5 valence electron pairs. Now, among carbon and nitrogen, this is carbon, this is nitrogen, put a bond, right? Now start filling the octet of this nitrogen. 2, 4, 6, and 8. How many I had? 5. Out of 5, how many I've used? 1, 2, 3, and 4. One more will be here, 5. Octet of this nitrogen is complete. But what about this carbon? It's not complete. So what you need to do? Remove this, put a bond. Remove this, put a bond. Octet of both the atoms is complete now. Now it's time to calculate the formal charges. Call this is atom 1, call this is atom 2. Formal charge on atom 1 will be equal. First of all, how many valence electrons nitrogen has in non-bonded state? 5. Minus in bonded state 1, 2, 3, 4, 5. Right? So 5 minus 5 comes out to be 0. Look at the second atom, carbon. Carbon in non-bonded state, how many valence electrons it has? It has got 4, right? It has got 4. Minus. In bonded state, 1, 2, 3, 4, 5. So 4 minus 5 comes out to be minus 1. Right? So these are the formal charge on the atoms too. So my dear students, this is how you calculate. This is how you calculate formal charges and you draw the structures. Okay? Right? If you ask me what is the significance of this formal charge, what kind of information? By the way, this is something which you can try on your own. Calculate the formal charge and first draw the structure of it and calculate the formal charge. Similarly, draw the structure of it, calculate the formal charge. Draw the structure of it, calculate the formal charge. These are some homework questions which we have. Now the point is, what is the significance of the formal charge? Why are we calculating formal charges? Look at these two statements and it's done. The main advantage of formal charge is that it helps to select the most stable structure. Formal charge is one of the factors by means of which you can identify the most stable structure of the molecule, right? And how do you identify exactly? Out of the one with the least energy, out of different possible Lewis structures, the most stable is the one which has got least formal charge. So that molecule wherein you see least formal charge, that's going to be most stable. Am I clear? Just these two statements you have to remember. You can remember them directly. So formal charge is one of the factors by means of which we can talk about, we can select the most stable structure of a molecule. And that structure is going to be most stable, wherein formal charge is going to be minimum. That's all. Okay? I believe I'm clear till here. Guys, my throat is aching, right? It's paining a bit. So I think I'll keep the session this short only for today. Tell me once in the chats if all the things are clear. It's Wednesday today. So let me tell you I'll be completing this chapter overall in 3 sessions, out of which first session was today. When will the second session? Tomorrow it's 15th, 16th, 17th. On 17th of August, we'll have part 2. We'll have part 2, and on 20th of August at 7 p.m. we'll have part 3. So we'll complete this particular chapter in 3 sessions, right? Timing is going to be same. That is going to be 7 p.m. I hope all the things, whatever things I've taught you today, I hope all the things are clear to everyone, okay? And in the next session, we are going to start with the Fajan's rules, right? Basically, my throat was not well since yesterday. I kept on cancelling the plus classes as well. I mean the platform classes. Okay. And PDF of this particular session I'll be sharing on my Telegram, which is Wasim Bhatt Chemistry Official. If you're not there, join that particular group, right? Yeah, it was a small lecture. Okay, in the remaining 2 lectures, we'll complete it all. And the next lecture, second lecture, is going to be on 17, right? Be there. And right after this particular session, do let me know in the comment section of this particular video whether you actually loved the session or not, whether you got your concepts, whatever concepts I taught you in the session, whether you got them cleared or not. Do let me know in the comment section of this particular video, right? So I'm taking a leave with this. It's getting tough for me to talk over here.